All right, so in today's presentation, I'm going to go over sustainable building metric. Okay, so some of the questions we're going to answer here, you can read basically how do buildings impact sustainability, and we're going to look at some of the different sustainability rating systems out there. But first, to provide a little bit of context, if you look at the impacts of the building sector in the United States, so just the buildings in the U.S., these are the approximate numbers. So, of all of the water used in the United States, about 12% is used by buildings. Okay, so of course there's a lot used in farming and some other purposes, but 12% of all water in the U.S. is used in buildings. Now we're getting somewhere. Almost 40% of the CO2 emissions in the United States. So think about all the transportation, the cars and the airplanes and everything. About 40% of all of the emissions come from buildings alone. About 65% of waste output. I mean, a huge chunk. This is mostly from construction, but some other things as well. So a huge amount of waste comes from buildings. And then 71% of all electricity in the United States is used by buildings. So this is, hospitals and churches and commercial buildings, industrial buildings, homes, apartments, everything. Okay, so this is all buildings combined. And you can take these numbers, with a grain of salt. They're all about approximate numbers. About 70% of all electricity, 65% of waste, 40% of emissions, 12% water use. So it's a big deal. We really should be concerned with, if we're concerned with sustainability, we should really look at the building sector because it's a huge chunk of our sustainability impacts. And of course, you always want to keep in mind the 3 E's of sustainability. Okay, so the first one we're going to look into is called passive solar design. This is strictly an energy consideration. So passive solar design just means basically utilizing the surrounding conditions to reduce energy use in a building. Again, this is based on energy, but you can think of it as working with nature instead of fighting it. I mean, the primary reason we build buildings is to prevent the elements from getting inside and protect ourselves from the elements. And so while that's an important use, what passive solar design is, it seeks to actually use the elements or use nature and the prevailing conditions around you, the ambient conditions, to your advantage. Okay, and we'll go over that in here in a minute. So there's 5 basic design principles. We have orientation, shading and overhang, insulation, windows, and thermal mass. And we'll go over these in more detail here. Okay, so first of all, we have orientation. So orientation is all about basically which direction the building is faced. So if you have a good southern exposure, so this is in the northern hemisphere, think about which direction your building is faced. Okay, and so if you think about the northern hemisphere, which is where the United States is, if you would look at where the sun goes through the sky, right? It rises in the east and sets in the west. So all year long, the sun rises in the east and sets in the west. So in the summer, yes, it's higher in the sky, but it's still to the south of where you are. In the winter, the sun spends the whole day south of you. So in the northern hemisphere, the sun is almost always to the south of wherever you're standing. Okay, so in order to take advantage of sunlight, especially in the wintertime when you want to absorb the sunlight, you need to have this south-facing building, and you need to have windows on the south-facing side, which we'll get to in a minute. Okay, so this is really important. In order to maximize the amount of energy that you absorb, the amount of solar energy that you absorb, especially in the wintertime, you need to have your building faced south. And you want to have the building should be facing as much as possible east to west on the long side. You also want to do nice things that take advantage of prevailing winds, and we'll talk about shading in the summer as well. And you do want to think about the design for 12 months. In other words, you need to think about what's going to go on in the summer, what's going to go on in the winter, what's going to go on in the spring and fall. So you want to think about year round. But orientation just refers to compass direction, which I'm sure you learned a long time ago, right? Like you have your compass here. So you have south, north, east, and west. Okay, so you want your building as much as possible if this is where you're doing. So if this is your building, the long way should be facing south. So the sunlight, in the morning, you're getting your sunlight coming in from the southeast. In the afternoon, it's coming from the south. And then toward the end of the day, the sun's going to be coming in. Okay, so if you have your building face south, right, you're going to get sunlight coming in pretty much all day long. Now, of course, in the summertime, that's not such a good thing, but we'll go over some ways that you can prevent the sun from coming in the summer. And then really what you're doing is taking advantage of the winter sun. Okay, so that's orientation. It just means the direction that you're faced. Okay, so overhangs and shading is the second principle. And so this has to be used in combination with your orientation. And so the way, kind of boils down to keeping the sun off the glass in the summer and let the sun fall on the glass in the winter. Okay, so again, combining your orientation. So you want a south-facing building. And this is a nice little diagram that shows you the benefits of having an overhang. Okay, so if you have your overhang here, so if this is south, this way is south, you have your overhang oriented correctly. In the summer, the sun is going to be higher in the sky, right? So the sun path is higher in the sky. It's lower in the winter. So in the summer, the sun's coming in from a high angle like this, okay? And so if you have an overhang, a proper length of overhang, then it's going to block that summer sun, right? So this is all going to be shaded here. But in the winter, when the sun comes in at a lower angle, if you have a nice little window here, you're facing south, you're going to get that summer sun. So in the fall and in the winter, so this is kind of your fall light and spring light, and then in the winter light, you're going to actually get the sun coming in your south-facing window. And there are other means, I'll go over this in a minute. So here's another little diagram that I think kind of helps. So if you have your overhang here, and if you have your summer sun, so in this case, if you have your summer sun, so it's coming in, and you see if it's kind of coming in at this angle, it's hitting this overhang here. Now, if this overhang were not here, if you kind of cross this little thing out, okay, if you cross the overhang out, the summer sun is going to come down and go, it's going to end up in your window, right? So if this overhang's not here and the sun angle is like that, it's going to come in your window, it's going to come like that in your window. And the same thing here, if this overhang wasn't here, then this sunlight in the summer could end up going right in your window, okay? But what's nice about it is the overhang is small enough that the winter sunlight's coming in, and then, it can come in at lower angles. And so there are other things that you can do. Another way to do this, if you have trees, so if you have some, right, so if you have a deciduous tree that drops its leaves in the winter, so in the summer, the sunlight's coming in, it's going to hit your tree, right? And then in the winter, if the leaves drop, then the sun can go right through, okay, and it can pass through. So that's another way. You can have other things, another vegetation. You can have vining plants, grape arbors, that sort of thing. So the key here is that you want to allow the winter sunlight to come in, and you want to have the summer sun blocked, okay? And that's the principle of overhangs and shading. And here's just another little diagram that shows you a little more detail. Okay, so we have insulation and air sealing I like to add. So insulation and air sealing is pretty standard. It's basically, you want to have insulation and air sealing. They basically prevent the heat from leaking out in the cooler months, and they prevent heat from coming in the warmer months. And so it's pretty common sense, you want to have nice continuous insulation, good air sealing so you don't have air leaks like this. So you don't want to have stuff that looks like this. You want to have nice continuous insulation that's really well done. That's, I think, pretty common sense. Okay, then we have windows. Okay, so this is the fourth principle, is windows. Again, you want most on your south side. You want to limit the east and west, and you don't want to have too many windows. One of the problems with windows, windows are very poor insulators. So this is a lot of windows. I mean, this would be nice for a sunroom, but if this is your main house, you might be in a little bit of trouble, because although it's great to have that nice winter sun come in, you get the nice natural light, the problem is the windows are really bad at insulating. They're really bad at keeping the heat from moving. And so you might end up with a really cold room anyway, especially at night when the sun goes down. There's just really nothing you can do. You can put some nice blinds over top, but it's not going to totally compensate. So you have to be careful about not overdoing it. But the real key here is you want to combine all these principles. You want to have a south-facing house with overhangs and shading, and then nice windows on the south side with insulation in the rest of the house. Okay, so the last principle is thermal mass. This one's a little bit interesting and not something I think that people think about a lot, but as you know, in your article they say what truly sets this passive design home apart from standard is the thermal mass. So a thermal mass is a material like there's certain types of stone and concrete. Soil is a really good thermal mass. Water is a really great thermal mass. So the thing about a thermal mass is it takes, as it says over here, it takes a long time to heat up and a long time to cool down. So just imagine if, so this is a thermal mass. And so if you have these nice, again, use everything in combination. So let's say this is your south-facing wall. You have windows here, and you have your winter sun coming in. So what's great about a thermal mass is it'll slowly, very slowly absorb the heat. Okay, so it won't heat up really quickly. So in the wintertime, it takes a long time to heat up, but what's really nice is when the sun goes down, it takes a long time to lose the heat. So very slowly, you'll feel, I mean, you'll feel at night, if it's a good thermal mass in the middle of the winter, if this is heated up during the day, you'll feel that the floor is still warm. Okay, so that's what a good thermal mass does. It takes a long time to heat up and a long time to cool down. And so it's nice in the cooler months because if you can get it to heat up, then it'll keep the house warm overnight. But in the summer, if there's any sun that's hitting it, it actually takes a long time to heat up, and it'll hold that heat and only release it very slowly, so it doesn't get hot. So if you have a floor that's not a thermal mass, it can get hot really fast, which gets really hot in the summer. And so it just kind of overall keeps the temperature a little more cool in the summer and a little warmer in the winter. Again, this has to be combined with all of those things in order for it to be most effective. And if you think about the old style furnaces, they had, you think about the old furnaces. So if this were a furnace on the wall, you would see this nice big stone hearth around it. And so the stone is a good thermal mass. So during the day, if you have a furnace, and I'll show you this in a video here in a minute, the thermal mass will slowly heat up all day long. And then when you turn the fire down at night, it'll actually release that heat out into the room at night. Okay, so thermal mass is what really sets a passive house apart from others. It's not too difficult. You get orientation is good, windows are good, insulation is good, but what really makes a house nice, a nice efficient house is the thermal mass. Okay, so let's look at a video that kind of combines a lot of these elements.
We're designing the Honda Smart Home to achieve net zero energy goals, which means that on an annual basis, we'll be producing as much or more renewable energy as we consume from the grid.
So notice he said net zero energy, which is an important term. That means you're using just as much energy as you generate. So if you need to basically, at the end of the year, as much energy as you use in the house, you need to generate just as much by using renewable energy sources.
We'll be producing as much or more renewable energy as we consume from the grid. We want the house itself to be very energy efficient. So we started with a concept called passive design. This is an old idea, but we're really trying to optimize it by applying some very modern design tools. But it's not enough to just put a bunch of solar panels on the roof. We really want the house itself to be very energy efficient. So we started with a concept called passive design. This is an old idea, but we're really trying to optimize it by applying some very modern design tools.
So notice he said we're building a building to work with nature, and so that's the basic premise of passive design.
As much as possible, and this lets you really reduce the amount of energy that's needed for heating and cooling. So we're looking at how do you work with the local climate conditions? How do you position the house on the site for maximum efficiency? And then how do you build the outer layers, the shell that we call the envelope?
Avoid the use of air conditioning next day. This is the south side of the building here. And as you can see,
Davis happens to be a really great place to apply these passive design techniques.
we are in the valley, Central Valley.
So you see these overhangs, and they show this, if you notice the time moving forward, this overhang is shading, creating shade for those south-facing windows in the summer.
The south side of the building here, and as you can see, there's overhangs up above here and on the first floor, which shade. Provide free heat. The envelope is the outside of the building that basically separates the indoors from outdoors.
So the envelope is where you do the insulation and shading. It's called the building envelope, or I mean the insulation and air sealing.
So keep the sun out from inside the house during the summer, but when the sun's angle in the wintertime, it allows that sun in to provide free heat. The envelope is the outside of the building that basically separates the indoors from outdoors. The slab is fully insulated because we are heating the house. It's cooling the house through the... So that's your walls, your windows, your roof, your floor. So the elements of the house include a double stud wall, triple pane windows. The roofing material is a cool roofing material which reduces the amount of heat gain. The slab is fully insulated because we are heating the house and cooling the house through the floor, and we want all that heating and cooling to actually get into the space and minimize the loss to the ground.
So what we're doing today is we're sealing the Honda Smart Home here at Davis. And what we're using is a new technology that we're developing for sealing envelopes using an aerosol spray. And
so that's, just so you know, a really advanced air sealing technique that's very uncommon, that's expensive and advanced, but it's a great way to really tighten up a house and prevent leaks.
Apply the spray, so the aerosol fog on the inside is kind of driven to the leaks by the airflow, because when you pressurize the building, the only place for the air to escape is through leaks in the shell.
Meet California's zero net energy goals. By using these passive design techniques, we're able to really reduce the amount of energy required for heating and cooling the home. This lets us use much smaller mechanical equipment that's also very efficient.
California's goal is to build zero net energy homes by the year 2020. So this house,
75% less energy than a typical home. And one thing that is interesting, if you have a really efficient home, the HVAC, so the heating and cooling systems, can be much smaller because it's a lot easier. You're not losing all this heat and you're not losing all the cold air. So you can actually save money on your some of your other systems in your home.
Passive design really is the first step to achieving your net zero energy goals.
Okay, so that's a pretty good introduction to passive solar design. So notice it's utilizing the surrounding conditions to your advantage, basically. And just in case you think that this is a brand new idea, he did mention that this is an old idea that they're putting a new spin on. But you did in some of your readings this week, you had some examples of how they used it in these 5 principles in ancient times. So this is a cliff dwelling. This is from your reading. Excuse me. And this is Mesa Verde National Park in Colorado. So this would be your south-facing wall. So they actually carved these dwellings outside of the cliff, out of the stone. And you can see here, it's pretty clear that there's this nice big overhang. So even the Native Americans, I'm not sure how long, and this is hundreds of years ago that they built these, and they understood that it was good to take advantage of the summer sun. I mean, this is, in deserts they tend to get really cold at night, and so but really hot in the middle of the day. So they use these overhangs to prevent the sun coming in at night, in the day, but they can still get sun in the evening and also in the wintertime. In ancient Greece, they designed whole cities that were oriented south. Rome also, ancient Romans understood this as well. Romans actually developed a type of glass that was out of mica, which is a rock. And so these are, they've been doing this for thousands of years. They understood these basic design principles, this orientation, this overhangs and shading. They actually used insulation. So some of the old mud brick houses in the southwest United States, they built these walls thick enough that they actually insulated from the hot summer sun. So there's all these principles that they actually understood these. It's kind of like we're just sort of getting back to doing this again nowadays. Okay, so a passive house is this concept. It combines very little energy, so it's possible to live in without a traditional heating solution. So there's a couple of different definitions of this. Okay, so let's look at another example of a really cool passive house that I wanted to show you.
Let's suppose that you're writing a really important email to a colleague.
This is Cobb. Cobb gives you excellent thermal mass heat storage. So it's a critical part of a successful passive solar design. A building that's going to heat itself and cool itself as much as possible needs thermal mass as well as insulation. Here on the north side of the building, for better insulation, we use straw bale.
So this is straw bale, which is actually exactly what it sounds like. It's bales of straw, and you'll see some details of that in a minute.
Thermal mass, like Earth, is a completely critical part of an effective passive solar design. This is designed as a passive solar structure, So the thermal mass of the cob is on the south side of the building where the sun hits. You can't build a good passive solar house out of 2x4s and sheetrock and styrofoam insulation because you don't have the mass. So this is actually a hybrid structure. The back, the part to the left of this wall is straw bale, and the part to the right is cob.
So in case you missed it, this front part is called cob, C-O-B, and that's a good thermal mass. It's a natural building material. And the back side is all straw bale, which is a really good insulation. So this is the north side where you don't need as much thermal mass because the sun is going to come from this direction. And so this absorbs that nice summer heat, nice winter heat, and prevents some of the summer heat from coming in.
Straw bale and cob hybrid buildings are very common.
So here you can actually see the straw bales in the walls.
What you tend to see is straw bale walls on the north side of the building where you most want your insulation, and cob on the south side of the building, the part that gets hit by the winter sun. So the cob can absorb the heat from the winter sun and re-radiate that into your building later to help warm it. That also makes sense because you tend to have most of your glazing, most of your windows on the south side. And if you want a whole lot of windows on one wall, straw bale ends up being a difficult choice to do that with. Straw bale on the north, and you see these big, pretty flat walls without many windows. That's straw bale. And so that's one very simple and obvious hybrid system, is something like straw bale on the north for insulation, cob on the south for sculpture and thermal mass. And this interior wall here, this is cob up this high, and the cob is here for thermal mass. It absorbs heat from the wood stove when the wood stove's going. It also absorbs sunlight directly in the winter coming through these windows. The midday sun shines on this cob and heats it up. The earth provides a lot of thermal mass, which heats up very slowly and cools down very slowly.
So in case you missed that, this is a wood furnace, and so this is all cob behind him. And so, as I was mentioning earlier, if you're burning your fire in the middle of the day, this is slowly absorbing that heat. And what's really nice is when you need to turn your fire down at night, this will then radiate all that heat back out all night long and keep it a lot warmer at night. It's a very, very comfortable way to heat a home.
So it's a really, really effective way to cool a house, particularly in a dry climate like this. Historically, if you look at hot desert architecture anywhere in the world, what you see is really thick masonry walls made out of earth usually or stone. Those walls hold the coolness from the nighttime and very, very slowly heat up during the day. The way we do it here, at night we open up all the windows and we let the cool night air come through the house, and that discharges any heat that's been stored up in the thermal mass during the hot day. And then in the morning we close up all the windows and just keep that coolness locked inside the building. In the winter it works pretty much the same way, except of course you don't open the windows at night, you leave them closed. And the sun, the low-angle winter sun shining in through the south-facing glass, that heat is absorbed into the thermal mass. Really good place for that thermal mass is in the floor. So we do these earthen floors in most of our structures. This is just made out of clay soil, sand, and straw, and sometimes gravel. And it's about 4 or 5 inches thick. And so the winter sun coming through hits on the earthen floor. The floor heats up during the day, as do any thermal mass walls that are close to the south side of the building and are also hit by the winter sun. All that heat is trapped inside the building, and then at night when the sun goes down and the air temperature drops, the heat works its way back out of the thermal mass and heats the space.
Okay, so that's another really good example of passive house principles in action. Okay, so cob, that should only be 1B. So cob as a thermal mass is a really good thermal mass. Okay, I'm going to leave it there for now, and then I'll pick up with the final part of the video in the next section.